This is our AP Calculus review. This is the 5 for 5 series, version 3.2, and the 5 for 5 series has to do with taking a set of 5 problems to kind of hone your skills and also gauge in progressively harder problems your readiness for next week's test. So we're going to look at problem 1. A particle moves along the x-axis with velocity given by v of t equals 3t squared plus 6t for time t is greater than or equal to 0. If the particle is at position x equals 2 at time t equals 0, what is the position of the particle at time t equals 1? So really our distance is equal to our integral, in this case from 0 to 1, of v of t dt, except our position, we have a starting position of x equals 2 at time t equals 0, so that's a necessary piece of information. So we're going to have 2 plus. Now in our calculus problems, most of the time you're not given superfluous information. Usually the things you see are needed. So we're going to have this limits from 0 to 1 of 3t squared plus 6t dt. And then, so our position is going to be equal to 2 plus, we're going to take the integral of 3t squared, which is going to be 3t cubed, divided by the power we raised to, which is 3, plus 6t squared over the power we raised to, which is 2. And we're going to evaluate from 0 to 1. And just continuing to the right, we have 2 plus, we have 3 over 3 cancel. We're going to have, we'll say 1 cubed plus 6 over 2 is 3. We're going to have 3 times 1 squared, which is going to be equal to 2 plus 4, which equals 6, which gives you answer choice B. Now where you could get into trouble is if you just happen to forget about the starting position of 2, you might have picked A incorrectly. Next, 2. We have the integral of sine 2x plus cosine 2x dx. And what I try to show my students is a little thing here called Snow Cone Santa Claus, which I'm writing here at the lower right. And what that is, it's a little graphic device that helps with finding the integral and the derivative. In the case of the integral, we need to rotate counterclockwise. And so sine becomes negative cosine, and this cosine doesn't become negative sine, just regular sine. So what we're going to be left with is a negative cosine and a positive sine. So we can cross out everything that doesn't meet that requirement. So we're going to have negative, A is both positive, C is both positive, D is cosine positive and sine negative, but we need a negative cosine and a positive sine. So we've already eliminated 3 answer choices based on that. The last thing we're going to need to do is kind of check to see which one it's going to be, B or E, and to do that we can do a U-substitution. We'll say let U equal to 2x. And so du is equal to 2 dx, and so dx is equal to du over 2. So we're going to get a division by 2 type thing going here, and what that's going to do for us is solidify B as our only possible correct answer. Next, 3. The graph of the function f shown above has horizontal tangent at x equals 2 and at x equals 5. Let g be the function defined by g of x equals the integral from 0 to x of ft dt. And what this is this is something called having the integral as a function. And so this f here is equivalent to g prime. Okay, so we're going to keep that in mind. So this would be like the graph of g prime. And we have a little device that we try to keep track of the f double prime. We put next to f plus minus, then increasing, followed by decreasing, and then concave up, concave down. And immediately under that we put f prime, and f prime is going to be plus or minus right under increase and decrease in the original function, and then we put increasing under the concave up and decreasing under the concave down. And finally, our last row, f double prime, we put plus under the f prime increasing and minus under the f prime decreasing. And so in this case, what we're looking for is a point of inflection, and that is where the function concavity will change from positive to negative or from negative to positive, and that's going to occur where the f prime function, or excuse me, g prime function, which is equivalent to f, changes from increasing to decreasing or from increasing to decreasing. And that occurs in two places, at x equals 2 and at x equals 5. So therefore, C is our correct answer for that one. Next, 4. And 4, we had only 40% of the original test takers get this one correct. I had a little more trouble with this one than I did with 5. What this is a composition of functions. And a composition of functions, what you have is you take this f of ln x. We're going to take this ln x and plug it in every place we see an x here. So we plug it in for x in both places. So we're going to end up with f of x is equal to ln x, but we're going to square that, and it's going to be plus 2 ln x. So we just replaced x with ln x. And so we're trying to find d dx of that, and so that's going to be like f prime of this. So we're going to take, using the chain rule, we're going to have 2 ln x times the derivative of the inside. Well, the derivative of ln x is going to be 1 over x. And then we have plus 2 times the derivative of ln x. Well, that's going to be 1 over x. So what that does, we have a common denominator in each case. We're going to have 2 ln x plus 2 over x, meaning that our correct answer is A. Well, again, I had a little bit of trouble with this one. Now, the last one we're going to be looking at, only 20% got this one right. So let's take a look at it. The xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of y equals x squared plus 3x plus 1. What is the value of k? Well, the first thing we're going to do is look at this line. If we have x plus y equals k, we can solve for y. Y is going to be equal to k minus x. And so therefore y prime is going to be equal to k simplifies to 0. We're going to have y prime is equal to negative 1. And now we're going to take this function here, this y equals x squared plus 3x plus 1, and that's going to be y prime is equal to 2x plus 3. And then we're going to take this negative 1 here and replace this y prime over here, because we know that's, we're going to have that. So we'll say negative 1 is equal to 2x plus 3. And we just solve for x. So if we subtract 3 from both sides, we're going to get negative 4 is equal to 2x. Divided by 2, x is equal to negative 2. And now we can take this x equals negative 2 and plug it into the original function, and then use it to get the value of k. So, doing that, we have y equals negative 2 squared plus 3 times negative 2 3 times negative 2 plus 1. And what we get for that is negative 2 squared is 4, and 3 times negative 2 is minus 6, and we have plus 1. So 4 minus 6 is negative 2 plus 1 is going to be negative 1. So we're going to have y equals negative 1. So we go to this function here, y equals k minus x, and we're going to say negative 1 is equal to k minus, what was x equal to? X equal to negative 2. So k plus 2, k1 equals k plus 2. And if we subtract 2, we're going to get k is equal to negative 3. So yes, there are a few steps to this one, but k equals negative 3 is our correct answer. Well, good luck in continuing to prepare for your test. I hope this has been helpful to you. And as always, thanks for viewing.